Okay, so today we are going to be solving systems of equations. Solving systems of equations, and you can solve a system by writing equivalent equations till the value of one variable is clear. Then substitute and solve for the other variable. You can solve a system by writing equivalent equations until the value of one variable is clear. Then substitute and solve for the other variable. So the technique you're going to use today is called substitution. And you're going to be asked to solve by substitution. And you're going to be given what's called a system of equations. You're going to be given two equations. And let's say, for instance, we have 3x plus 4y is equal to 12, and 2x plus y is equal to 10. Now, when you're solving by substitution, you are going to solve for a variable first and then substitute it into the other equation. Here's what I mean. When you look at these two equations, in this bottom equation, there's a y sitting by itself. So in that equation, the easiest thing to do would be to solve for y. So if we take that equation, which is 2x plus y is equal to 10, and we subtract 2x from each side, then we get a y that's equal to negative 2x plus 10. We have an expression that y is equal to now. So we go to the other equation. We go to this top equation, and where there's a y, we substitute negative 2x plus 10. Okay? So we rewrite this top equation as 3x plus 4, and instead of writing the y, we write the expression that's equal to y. So minus 2x plus 10, and that equation is equal to 12. Then we do the distributive property. So 3x minus 8x plus 40 is equal to 12. We combine like terms, so 3x minus 8x would be negative 5x plus 40 is equal to 12. Subtract 40 from each side. We get this negative 5x that's equal to 12 minus 40. Is negative 28. And then divide both sides by negative 5. And x is equal to 28 divided by 5 is 5.6. Now we have an x value. Once you have this x value, you can go back to either one of the original equations. Equation top one or bottom one. I'm going to use the bottom one because there's nothing in front of the y. So your next step, we know what x equals. We're going to substitute what x equals into the equation. So we take 2 times 5.6, 6, plus y equals 10. 5.6 times 2, 11.2, plus y equals 10. And then subtract 11.2 from each side. So our y is equal to negative 1.2. All right, so when solving by substitution, the first thing we do is we take one of the equations and we solve for one of the variables. Once we have an expression for a variable, we go to the other equation and we substitute that expression for the variable. Solve for one variable, substitute, solve for the other. So let's take a look at another example. We're going to solve this next system by substitution as well. And here's what we've got. X plus 3y equals 5. Negative 2x minus 4y is equal to negative 5. When you look at both of these equations, since there's an x by itself, that would be the easiest variable to solve for first. So if we take x plus 3y equals 5, subtract the 3y from each side. So we get an x that's equal to negative 3y plus 5. We take that negative 3y plus 5, go to the other equation, and substitute it for x. So we're going to take negative 2 times what x is equal to, which is negative 3y plus 5, subtract 4y, and set it still equal to negative 5. So do the distributive property here. Negative 2 times negative 3y would be 6y minus 10 minus 4y is equal to negative 5. Combine like terms. We got a 6y minus a 4y, so 2y minus 10 equals negative 5. Add 10 to each side. So our 2y is equal to 5, and then divide both sides by 2. So we get a y that's equal to 2.5. Now I'm going to go back to that top equation, and I'm going to substitute the 2.5 for the y. So x plus 3 times 2.5 equals 5. So x plus 7.5 equals 5. And then subtract 7.5 from each side. So on the left-hand side, we get an x that's equal to 5 minus 7.5, negative 2.5. All right, so we've got a value for x, and we've got a value for y. Does anybody have any questions on solving systems using substitution? All right, then your practice for today is going to be on page 146. (14 through 18). Page 146, problems 14 through 18.